Welcome to day 4 of Advent of Code. This problem was a bit more fun, I think. Let's get into it. So we get a whole list of Xmas texts and we want to find the Xmas's in horizontal lines, vertical lines, diagonal lines in each direction. So our goal is to sort of transform the data in all different directions and then find or match the Xmas. Let's first import the data. Let's make it a bit bigger. File.lines, data.txt. There we have all the strings in the list, but because we are gonna do some transformations, it's nice to have it as a table. You can make it a table by just opening it up with that one. It's called merge. I guess you're merging all the lists together and making them ranks instead of lists. So to transform the data in all directions, I took inspiration from Zyma because he had a very cool way of doing it. Zyma is the implementer of BQN. He works on the language together with Marshall. And what he used was there's this common pattern of doing a transpose and a rotate. And these two together sort of rotate your data 90 degrees. So if I, for example, put a 3x3 shaped range of 9 numbers, you can see here's this list. And if we show it after this transformation, it got rotated where the 0 is now in the bottom left corner and the 2 is now up here. It happens because we transpose, which means this axis goes here and this axis goes there. And then we rotate, which on a table means the bottom goes up and the top goes to the bottom. And that results in this. And we can use this to transform our data to 1 times 90 degrees. So if you check the rows, then you're checking the columns. But you want all the rotations. And we have this cool operator called repeat. And that actually repeats the function on the left a given amount of time. You can give it a number, for example 2. And what would happen is this function gets applied twice. So now you can see it's rotated 180 degrees. It just runs the function and gives the output back to the function again. Another cool trick of the repeats operator is you can give it a list and it'll do the repetition for the amount of times for each number in the list. So if we do 1 and 2, you get 2 rotations, one with 90 degrees and the other with 2 with 190 degrees. And that way, if you give it a range of 4 numbers, that would result in, let's show that. That would result in 0, 1, 2, 3. And then we would get rotations of 0 times. So the normal thing, 1 time, 2 times, and 3 times. And we can give that the data. And we should just generate that beforehand. And that should give you all the different rotations. Oh yeah, let's keep the example. So here you get all 4 versions, all 4 rotations. So if you would now read the rows, you would get the rows, the horizontal, the other way around, from the top and from the bottom. And I think this is super cool. This is like a very neat way to express it. We can just give the data to this function, and that would give us 4 matrices of the text in all rotations. And that's very large, so I can't really show it. Yeah, so let's make this a function, like rots for all the rotations. And if you remove the argument, it becomes a function you can call, from which if you give it a table, you get all 4 rotations back. And first we want to check all the rows. So to check all the rows, we get all the rotations of the data. And then we just, for each of them, search in them. So find in each the string Xmas. And that should give us Boolean arrays with ones at the positions that there was Xmas. We can sum all those arrays together. That would give us 1 array with sometimes numbers bigger than 1, like 2, maybe even 3. Not 3, just 2. Yeah, you can't have 3 because they would be true on both sides, and it's not possible with Xmas. And then we should just fold up the table, so plus fold on the rows and plus fold on the resulting one. and that gave us back 188. But we're still not checking the horizontal lines yet. So we need to also find a way to do that. Zymer has a very cool example of that as well. He actually added padding to the right, the same width of the whole list, and then shifted each row by their index. And that made this very cool pattern where you actually sort of align the diagonals, and then you can check that. And that's a very pretty result, but that's not what I came up with. And I'm not going to copy this whole thing. So yeah, let's call this straight lines, something like that. And then we are looking for diagonals. And so what I came up with is the more brute force, less pretty approach of just creating 4x4 windows of all the data. You get back all the possible squares in which an Xmas can fit. So, and you can just check the crosses of that. And then you can count up all the Xmas's. So this would give us back a lot of nested squares, because this windows function, especially if you give it more access, gives us back nested arrays, or I mean higher dimensional arrays. And what I want is to nest all the 4x4 squares. You can do that by this function called enclose on things of rank 2, so every table inside. That gives us a lot of tables. Whoa, funky. Let's take a smaller sample size. 10 by 10 take. Yeah, so you get all these tables back, which are their own array now. And we can do the rotations trick on each of them. So now inside are, let's make this even smaller. Inside of each is 4 different versions, the different rotations. And it would actually be more performant to do the copying, creating the rotations first and then cutting them out. Maybe let's actually do that. So first create the rotations, then for each rotation create the 4x4, and then for each 4x4 enclose it in there. Should give us, oh yeah, this needs to happen for only the thing we have now. That should also give us 4 different options, but then they're all their own array. So every rotation has their own array, if that still makes sense. And then what we want to do is check on the diagonal if it says Christmas. And to check a diagonal, you can do a 0, 0 transpose. And that gives you back the diagonal. So if I do that for each, because we are going over each version of the rotations and then each list in that, then you get back all the crosses from that. So this is every rotation, it's cross, so all the possible crosses. And we want to check if they're Xmas. Also for each. That's the Boolean array. So this was a Christmas, we can see that there. And this was a Christmas, and the others weren't. And then we can fold it up again. If we do merge, then we get one big list. And we can destructure that. Or that's actually called deshape that. So we get a list, and we can add all the elements. Shabam, and then we have the total, and we did a subsection of it. So if we remove that, we get all the stuff. That should be all the diagonals. And we can just get the answer by solution 1, straights. Let's call this straights and diagonals. And then we have solution 1, which is this number. So the second problem was that we misunderstood the elf, I think, and that we weren't looking for Christmas, but crosses of mass. And actually that's not that hard to find now that we know this sort of logic. We can just copy these diagonals, and then instead of, let's call this masses, instead of doing 4x4, it needs to be 3x3 because we're looking for a shorter word. We can keep the rest the same, but we're looking for mass. And if we look at this now, If we hide that, this gives us back, let's take a smaller sample size again. That gives us back the masses on the hard diagonals on each thing. And one tricky thing is that these are all now different rotations, so they don't match up. So we should actually do it like I did last time, where we first make them these lists and enclose them. And then generate the rotations. So if we show that, now it becomes a lot of data again. Let's make it smaller. Oh wait, I made a mistake. It needs to go over each thing. Each thing needs to be rotated. So now every cell here, which is one check, gets 4 versions of all the rotations. And we can grab the diagonals from those again. That's what we're already doing. So these are all the diagonals from those. And we can check those for mass, which we're already doing. So that's a Boolean array. And actually what we should do is add up these Booleans, because that means if they're in the same position and it's a diagonal match, or the other way diagonal match, or that way, then they should count. And we can just add them because you can never have the opposite diagonal match, because mass and SAM is different, essentially. So we can just add fold all these arrays, and there you get your mask. And if it's 2, if there are two things on it matching, then we have a correct match. So we check if it's true 2 on each thing. So only this one now is a cross of masses, and then we should fold up that thing again. So plus fold over the rows, and plus, or over the major cells, and plus scan. And there, oh, if I show that, there is the answer, but we need to include all the data. And that should be the answer. Let's show them both. I call this solution 2. Let's delete that. And if we check, this should be it. If I check my original, yeah, it's the same. So I think super cool. There's a more pretty way to do it, like Sam I did, or there's probably even more ways. And Windows is not the most efficient, but it is quite doable. I think you could see what was happening quite well. And it's just really fun because rotating like matrices of text is quite native to array languages. So mass of X masses. Okay, I will see what I can do for the other videos, and I really like them. I want to continue. And if you have any suggestions, or if you like it, you can leave a comment, and I know, because it doesn't have much attention in the videos. I'm mostly doing it to put out some content and to share the experience of using BQN. So yeah, thank you for watching.